Welcome, robotics students, to the fifth in our series of videos for distance learning. This one's being created and uploaded on Thursday, April 14th. Before we get into things, we're going to go to the PowerPoint, just like you would see in the classroom. You'll see at this point we have 5 assignments that are past due. If you turn those in, those are graded, recorded in progress book. If you do not get those turned in, they're recorded as missing, and you can still turn them in for full credit. I've had several students log on both yesterday and today and do all 5 assignments in a fairly short period of time. You have another assignment that was assigned last Thursday, and it's going to be due this Friday. So you'll have had over a week to do it. It's called the End Effector Challenge. You're trying to create a gripper that goes on the end of a robotic arm and picks up a ball out of the middle of a circle. You're supposed to be working with materials that you have available at home, and there are examples of how to make them, the materials that you can work with, and instructions on doing this assignment. Those are all in the video that was uploaded last Thursday. I'm going to show you an example of one of our 6th grade students. His name's Josh, how he put his together. So we'll take a look at that video right now. Okay, Josh met the requirements of the challenge. He was able to pick up the ball without reaching inside the circle. He was able to grip it, not scoop it or push it, and then put it outside the circle. Josh went beyond the assignment because he has an articulated arm. It has a shoulder and an elbow, and he did not need to do that, but it's fine that he did. All you really need to do is have an arm with a gripper type device at the end that you can pick up the ball out of the middle of the circle without putting your hand inside the circle. Today we're going to get ready to do another hands-on assignment. That assignment will come to you Thursday, but today we're going to look at some of the technology behind COVID-19, which is the reason we're out of school right now and doing distance learning. With the outbreak of COVID-19, millions of people are relying on face masks for protection. Yet face masks are complicated. Which mask provides protection from viruses? Do dust masks used in manufacturing provide protection? It's like the one that the guy in the picture is wearing. Do surgical masks capture coronavirus particles? It's certainly a face mask, but are the holes in it small enough to catch the particles? Do I have to use an N95 mask to protect me from flu causing viruses? Before we can answer these questions, we need to know how big coronavirus particles are. Scientists have already used electron microscope to measure the size of these particles. And you'll see this is an electron microscope, and these are the screens that he would use to observe what he's seeing. It's so detailed that this is what the head of a housefly would look like. Coronavirus particles are spheres. In other words, they're shaped like a ball with diameters of approximately 0.125 microns. Okay, so a couple of things here. The corona of the sun is what you would see that's glowing around the moon during a full eclipse of the sun. This is called the corona, and that's where the coronavirus gets its name, because it's basically a ball with these little particles sticking out all the way around. So that's the corona name. Next thing is 0.125 microns. What the heck's a micron? If you had a line 1 micron long and cut it in 8 pieces, each piece would be 0.125 microns long. So this white line represents the diameter of the ball, the ball shape of the COVID-19. If you took that line and you divided it in 8 parts, the COVID-19, this is the size of it, and that's 0.125 microns long. It's the 1/8 the length of a micron. So how big is a micron? A micron is so small you cannot see it with the naked eye. That's why scientists use electron microscopes. To put the size of a micron in perspective, it's helpful to compare it to some other things. So first of all, this represents beach sand on the lower left-hand corner of the diagram. So beach sand, we've all seen it, and this says fine beach sand. So it's the pretty fine stuff that you would see like on the beach down in Florida. Next comes the human hair. It's 50 to 70 microns across. You see that little shape that looks like a U and an M. The U stands for micro. So 50 to 70 microns apart across a human hair. And we can see that. Next, we would have dust, pollen, and mold. If you've seen mold before or pollen and it goes in the air, you can see those little particles. Each one of those would be about 10 microns across. PM 2.5, that would be 2.5 microns apart across. And this is usually the designation for particles that can cause harm, that can be inhaled and ingested into your body and cause problems. So that's PM 2.5, and you'll see that fairly often. So we're talking about something smaller than the PM 2.5. In this chart, it says the same thing up here at the top. How big is it? We can see a coffee ground. We've all seen coffee grounds, and that's pretty big compared to these other particles. Beach sand, once again, table salt is smaller. A human hair is smaller. Pollen is smaller still, and that's at about the limit of visibility. When it gets smaller than that, we can't see it. Next, we'd have white blood cells, smoke, red blood cell, bacteria, and a micron is even smaller than bacteria. So that's 1 micron is that little bitty dot. In this slide, it says the same thing at the top, but it says here the PM10, that's 10 microns apart across. A blood cell, red blood cell is next, 7 microns. PM 2.5, 2.5 microns. Bacillus, or bacteria in other words, is 0.5 microns apart. Coronavirus is even smaller. It's 0.1. It's saying 0.1 here. We're thinking of it as 1/8 of a micron across. Okay, the masks that are used in hospitals and the ones that are really good, they can filter 0.007 microns across. So much smaller. The coronavirus particles cannot get into that area. So this is just a little bit of talking about where the coronavirus, what it's shaped like, where it got that name corona, and about how big it is. What you're going to do next on Google Classroom today, you'll see a coronavirus video. Lasts about a little over 4 minutes. You're going to watch that. Then you're going to answer the coronavirus video worksheet questions. There's 10 of them. And if you don't know one, go back and watch the parts of the video that you missed. And you should be able to get 100 on this. I don't understand why some people are getting 20s and 30s on these worksheets when you've got all the answers there. It's not cheating. You're allowed to go back and look at them so you can make sure you get all the answers right. Because once you submit these worksheets, you can't go back and make a change. And I don't want you to make a face mask, but I want you to research ways that you could make a face mask. And then we're going to come back to that Thursday talking about resource materials and how you might go ahead and make one yourself. So I know today's video is pretty short, but you've got some things to work on, and I know some of you are still working on that end effector, so it gives you plenty of time to get things done. So going to see you again Thursday. Remember, Wednesday of this week is open house. I'll be sitting here for 4 hours. Hopefully your parents will be talking to me, and if not, I'm going to be calling home. And those students that haven't logged in yet, you'll be hearing with me in the next couple of days. We've got quite a few people that haven't gotten on Google Classroom yet, and they need to take care of that. So until next time, see you. Stay safe.